All right, I'm back and I'm talking to you about section 7.2. So we're continuing on the metric system. So notice that you have your notes and we're talking about length, area, and volume. So the basic unit of length in the metric system, as we kind of talked about that earlier in the last video, but we're going to talk about it a little deeper here, is as the meter. So about a meter, we said, is from the tip of your nose out to your outstretched hand, sort of your wingspan, is said to be about a meter. It's about 39 inches. In all English-speaking countries, except the U.S., it is spelled M-E-T-R-E, as you can see on your notes, spelled a little different, but it still means the same thing. And again, the meter is a little longer than a yard, about 39 inches, to get a thinking in your mind there, what it looks like. So a yard is about the distance of your wingspan, as I mentioned, and it is said that the English king, King Henry I, a little history here, in the 12th century, stretched out his arm from the tip of his nose to his thumb to give us what we now call a yard. I'm sorry, or what it was called a yard. Sorry, I was thinking the meter there, so I went off script. But anyway, that's what we called the yard. We're talking about the old English system and a lot of the old measurements that we used. And if you've grown up around here, you've probably been used to talking about yards and inches and feet and not as much about meters. So it's just customary. We call it the old customary units or the old English system. And then, of course, we're trying to convert you over to using the metric system, but it helps in your mind, whatever you're most accustomed to thinking about. If you can visualize it, it will help you whenever you're converting. Anyway, that's how we got our yard. Another one, it says in the 14th century, King Edward II of England ruled that an inch would be 3 grains, like 3 barley grains. If you put them end to end lengthwise, that made up an inch. And, kind of about like that, very tiny measure, an inch. So 3 grains of barley. Before that, it was the width of a man's thumb. So about the width of your thumb for an inch. So if you want to measure something in inches, you could kind of lay your thumb back to back. So about an inch. So these are not very precise measures, right? That's very different depending on the person. I mean, not super different, but somewhat different. It's not super accurate, though. And then, of course, you might guess the origin of the foot, right? What might that have come from? So when you ask what unit is most appropriate, think of what you would normally measure and use these guidelines. Here's just a few guidelines, I guess. If we're measuring something in miles, probably in the metric system, we're going to measure it in kilometers. If we're measuring something in yards or feet, we're probably going to measure it in meters in the metric system. If we're measuring something in inches, inches is close to centimeters in the metric, the closest measure. And then if it's super tiny, whatever super tiny would be, super tiny I'll call it, that would be in millimeters. Millimeters is a very tiny measure. If you can imagine your meter at about the 39 inches, the length from your nose to your thumb, if we divided that by 100, we're in centimeters. So 100, and it's about, about like that, close to what the inch is. I should have a ruler here, shouldn't I? I hope you're doing better than me. If you have a ruler, that would be even better if you were looking at a meter stick to see this real time. Millimeter, though, is going to divide by 1,000. So imagine this, just like a dot there. Not even that. Just almost can't see it. A millimeter is super tiny, right? All right, so that's kind of to give us the idea. Then in your homework, you have some questions. It'll say things like this activity. Just what do you think? And you can measure in whatever unit you want. So there's no absolute right answer here, but just what would be the most reasonable measure if you were measuring the distance from Lexington to Ashland. Now, you can measure it in millimeters if you want. It's going to be a whole lot of millimeters to Ashland to Lexington, but probably you'd measure it in kilometers, right? Kilometers, something that we normally think of as miles. Number 2, your height. How tall are you? I wouldn't measure that in miles, right? That would be, you could. It'd be a very small amount of a mile, but more reasonably would be the meter. So that's what we're looking at. I'd probably be about 2 meters or not, a meter and a half or something, but I'd probably measure it in meters. The length of your computer, so that's not very big. Maybe you'd measure that in a meter. It'd be a part of a meter, but you could also measure it in maybe the decimeters or which I didn't put here, or in centimeters. You could measure in one of these. I probably wouldn't measure it in kilometers though, right? It's not that big. And then the length of a gnat, you know, a little tiny bug, the gnat. So you probably measure that in millimeters, maybe centimeters, but maybe even in millimeters. So just to get an idea on those. Then let's talk about area. When we talk about area, these are just linear from here, point A to point B. We would call that one-dimensional if we were measuring a meter, for example. Or let me do like what I think a decimeter would look like. So, you know, a meter is here to the length of my hand, you know, down there. If I divide it into 10, maybe about right there. Maybe this is a decimeter, you know, a tenth of a meter. So, again, I'm sorry I don't have my ruler on me. I hope you're doing better there at your house. But let's say this is, I've measured this out, that's a decimeter. So if I wanted to do a square decimeter, I would have two dimensions, you know, 1 decimeter for the length, and then go that way, 1 decimeter for the width. So a decimeter by decimeter, if I fill that in, now I have a two-dimensional space. Say I was going to paint a wall or paint this rectangle. The area on that figure, that two-dimensional figure, we would say would be a decimeter, 1 decimeter times 1 decimeter. You would multiply decimeter times 1 decimeter to find the area, and 1 times 1 is still 1, but it would be decimeter times decimeter, so we call that square units when we do area. Again, for rectangular figures, we do the length times the width. This is a special rectangle, it's a square actually, they're equal, but we do the length times the width, so when you multiply those two together, that tells you the area inside that two-dimensional space, just flat, like if you were painting a wall or some flat surface, two-dimensional surface. So that would be 1 square decimeter. If you can kind of visualize, that is the area on 1 square decimeter. All right, another example I have here would be, say you have a box that's 4 meters by 5 meters. So back onto your notes here, it says, to find the area of a four-sided figure, such as a square or rectangle, you multiply the width times the length, like we just saw, and you give that unit in square units. You give that answer in square units. So if you had, say, 4 meters, and again, I won't be able to draw that accurately because 4 meters would be 4 of my wingspan, so that'd be too big to fit on the board. But let's just draw this and imagine this is 4 meters that way and 5 meters that way. And just to doodle this on the board as an example, something that's 4 meters by 5 meters would be 20 meters squared, or 20 square meters. All right, and then I have one more example on this page, a centimeter by a centimeter. You know, a centimeter is very small, about like an inch. So maybe an inch, centimeter by centimeter. 1 centimeter by 1 centimeter would be 1 times 1, 1. And centimeter times centimeter is centimeters squared. So the area on that flat surface two-dimensional space is 1 square centimeter. All right, next page. Note that a hectare is what they commonly use to measure in the metric system what we would use in acres. So that's what we're doing here, kind of if you thought about it as a big field of grass or something, if you were doing acres of land, 4 meters by 5 meters would be a small piece of land, but think bigger here if we were going to do something hectometer by hectometer. You know, a hectometer would be 100 meters, right? So going that 100 times, that'd get you pretty far down the road, right? So that makes it a bigger space. But just imagine I say this is 1 hectometer, and then I go this direction, 1 hectometer. That's 1 square hectometer. A hectometer times a hectometer, filling in, say, a piece of property, hectometer times hectometer would be 1 square hectometer, which they call a hectare, the area. So if they were measuring like how big a lot size was or a farmland or something, what we'd normally measure in acres is measured in hectares. And it comes from a hectometer times a hectometer. Again, a hectometer is 100 meters by 100 meters. All right, activity. Number 5, I've asked you to draw a box 1 centimeter by 1 centimeter to get a real thing. So if you're home and you have a ruler, I hope you do. If you can measure out what a real centimeter looks like, 1 centimeter that way by 1 centimeter the other way, and see real time what a square centimeter should look like, the amount of space it would occupy. Okay, like some big stone, maybe a big ring, maybe a pretty big ring, but anyway, about in that neighborhood, a square centimeter is about the size of a kind of a bigger stone that you might put in a ring or something. It might be a square centimeter. But anyway, to try to visualize that, if you can use your ruler, it would be better. All right, number 6, 7, and 8 say, determine the most appropriate unit of measure. So if you were going to measure the area on a nickel, I think this would be better. I might have one of those actually. If I was going to measure the area of a nickel, I would probably use square centimeters. It looks about like what I've got on the board there anyway. I'm checking my purse for a nickel. I feel like this nickel might just be, it's much smaller than my drawing on the board. I thought maybe, but still, I think that would be a fairly good measure. If you put a nickel onto a square centimeter, you'd have a close measure. You can measure things in any unit you want, by the way. I don't want to reiterate that. But the most reasonable, I wouldn't measure my nickel in square kilometers, right? What I would measure in miles, that'd be way too big. And in millimeters, be way too small. Centimeters seems a reasonable answer. It's centimeters by centimeters. It's medium small. All right, that's number 7, a nickel, I guess. Number 7. Number 8, that was number 6. Number 7, a baseball field. So it's not super duper big, you know, but so you could argue that one. I don't think there's a really one clear answer. I wouldn't measure it in centimeters, right? It's certainly bigger than the small measures, centimeters, decimeters, millimeters, no way. You could measure it in meters and make it meters squared. You know, a baseball field's going to have area that you're going to fill in. I know I didn't really draw an accurate baseball field, but it's going to have an area, you know, a length and a width that you're going to fill in. So we're still talking about area here for a baseball field. Maybe you'd measure that in meters, maybe in decameters, maybe you'd measure it in hecto for the hectares. So I think it's kind of questionable there. Any of those would work. I think I'm going to go with meters. I'm going to say maybe square meters might be good. See how many meters long and wide your field would be. And then lastly, the top of your kitchen table. So your kitchen table, I think meters would be good there. So definitely wouldn't do the small things like centimeters, decimeter, but maybe meters squared for that one as well. Again, no real absolute right answer there, just to get our brains kind of thinking about what these look like. All right, number 9. The next thing we're going to do, I'm going to need to do some explaining, I think, to convert 5 square centimeters to square meters. Now, normally in the last lesson, we would talk about how there's base units of meter, liter, and gram. So we're just talking about length here, so I'll just put the meter. Then we have prefixes, deca, hecto, and kilo as we go up. Then deci, centa, and milli as we go down. So the thing is, if we're doing 5 square centimeters to square meters, we are doing a 2-dimensional figure. So there is a 10 by 10 difference between centa and milli. Not only is there a difference the one direction, but there's a difference the other direction. There's 2 dimensions to it. So there will be a move of 10, the decimal point one place for the 1 dimension, and then another move for the 2nd dimension. We have to move the decimal point 2 times since it's a 2-dimensional figure. To get from a square centimeter to a square millimeter, for example, yes, it's 10, a factor of 10 between these two, but it's a factor of 10 lengthwise. You have a 10 difference of 10 between 1 centimeter equals 10 millimeters. So there's a difference of 10 that direction and this direction. So you wind up having a 10 by 10 difference or 100 square millimeter difference between square centimeters. 1 square centimeter would be 100 square millimeter. So you have to move the decimal 2 places for every move. From centa to meter, that's 1, 2 up, but I have to move double that 4 back. 1, 2, 3, 4. All right, so Before we come into the next one, if you can practice that a little bit on the activity.